Hi, I'm Sid from Citrix. And my question is regarding Kubernetes federation. So we know that etcd, Kubernetes mainly is driven by etcd, which is the storage, and which follows as per the CAP theorem is a CA system. And you cannot really have replicated etcd across regions. It can be done, but theoretically it does not work. So what is your take on that? And I had this discussion
Physics.
with the co-founders.
It's physics. So the way that etcd actually works is as the heartbeat mechanism is occurring, it's with that heartbeat that it's passing the messages. And until you get a quorum number of members within the cluster who confirm that a write has been confirmed to a disk, as in like you can stat the actual write and see that is there, etcd will not actually confirm that the write was successful. So if you have that brilliant moment of going, I know to make everything HA, I'm going to try to push it over a WAN or do a stretch cluster, you will run into a situation where it will probably work up until the moment you lose quorum across the regions, and then the maximum write speed that you would ever be able to achieve is 2x the speed of light between those, plus latency on the disk, network, et cetera. So if you actually read the academic paper that etcd is based on, which is a piece of software that Google wrote called Chubby, they actually have some interesting ways that they will federate information between clusters, where they namespace the keys, and then you can actually refer to the keys on a different cluster, and it will actually reroute the reads to redirect them over to another cluster. But it's very much an idea where you would either have, if you wanted true, like being nuked from low Earth orbit, you know, kind of California falls into the sea, you would have a separate job that would export the keys, move them over to the other system, or do more of like a streaming replication across to another site. But you also have to be asking, what does that buy you? Because if you're trying to do that for like Kubernetes, it's not going to get you what you are intending, because you've got an individual job with a UUID that if you try to reschedule that on another cluster, there's an, albeit extremely small, chance that you may run into a collision with another object or something else. I mean, it is a UUID, so it should be unique, but you then would have to create every single downstream object that correlates to that UUID, and it creates a pretty complex graph pretty quickly. So it's all about like understanding your failure domain and solving for the failure, not just doing the same thing you've done in the past of like, well, our HA is we run another copy and then we put all the data in 2 spots and we're good.
So the failover will be faster if we have the etcd replicated. That's the idea between regions, right? For the operational part of Kubernetes, the control plane. That's the whole idea of etcd replication.
Yeah, you're still talking about doing stretch clusters, though,
Yes.
which are a horrible idea,
Yeah,
and
that's what I was
is
getting at.
just, you are seeking to go down a path of pain to do that. Even if you make it work, you are still seeking to go down a path of pain.
And this is where federation comes in, like you were talking about. We want to make it very easy to run federation. So if you go on Operator Hub, there is a federation operator. And so running that control plane hopefully allows you to run many sets of clusters that aren't stretched, and then get workloads federated between them. And so that kind of paired with the automated operations model in OpenShift is, you know, running 5 clusters or 30 clusters or 300 clusters should be about the same amount of work for humans. At least we have a lot of robots behind the scenes doing that.
I have one more question.
Yeah.
So the distributed scheduling is an NP hard problem. And Kubernetes scheduler, if you see the code, it's a monolithic scheduler, which means that right now I heard last is that 5,000 nodes max. So the problem is when it's a monolithic scheduler, you cannot get the best optimized workload spread across the machines. It's always you're wasting resources. It does happen over the period of time. You can see the bulk papers and stuff, they talk about it. So they have done a lot of optimizations, but what about Kubernetes? I mean, what is the max number of nodes a single Kubernetes controller can run? I'm hearing 5,000 right now, but do you think you don't need to make a change to the scheduler itself to actually support more?
No, and I would say because if you are in a situation where you're trying to continue to run single clusters of 5,000 nodes, you are trying to create single 5,000 node points of failure. You are trying to be in a situation where when you have a failure in the control plane that is a hard down, that when it comes back, you're trying to reconcile state across 5,000 nodes. And I mean,
So put a different way, like more clusters, smaller amounts. And what we've seen too, and we run a bunch of large multi-tenant clusters called OpenShift Online and OpenShift Starter. And these things have like 10,000 namespaces, but they're not near 5,000 nodes. And so you're going to start hitting limits in like pod count and node count and pod density, most likely before you're going to hit the node limit, is what we found. And we separate those across failure domains. So we run at like 7 or 8 of those with about 10 to 20,000 namespaces each, which are big clusters, but that doesn't mean the node count is super high, because we want that failure domain too.
What is that node count that you have? Any ballpark?
They all differ, but I think between like 100 and 500 nodes-ish, something like that. And they kind of, they auto-scale and stuff, so.
Got it. Thank you.
Yep.
Thanks.
All right. Another question back here.
This might be a little silly, but with all these abstraction layers coming out, Kubernetes and OpenShift on top of each other, it's kind of like a proliferation of infrastructure just to have an infrastructure, right? Is there any notion that you're providing kind of the overhead? A lot of these things will do, like other operators, like Federation operator and whatnot, that are there so that your customers can have kind of a benefit analysis of like, is this going to be worth it, or I'm just making things more complex, I guess?
All right.
Nobody wants to take the hard one?
I think when you see how things like the top-level config that you input into an operator, or like this cluster that I just in the process of booting, where it takes 5 parameters and makes a bunch of smart defaults for you. The only way you can do that is by building on more like the lower-level APIs to surface higher-level, simpler APIs. And I think there is always going to be complexity there. But then you get the trade-offs like Redbeard was showing us with all the routing that like is basically impossible and out of reach for folks other than like the Yahoos and the Googles and whoever. And so it is definitely a trade-off there, and you need to figure out if that makes sense for your organization. Their like ops and engineering talent is always something to keep in mind.
All right, next question. I know a few of you have production stuff. The Pixar folks, you have no questions whatsoever?
But say, by the way, I am happy to lie and tell folks any way that they want, but just because I'm giving or start feeding you sugar for dinner doesn't mean your teeth won't rot out, and then you have to be spoon-fed. So.
All right. No other questions? There's one over there. Cool, thanks. I should have stayed on this side. This is between you and your reception and beer.
So would you please comment on how the runtime security is going to work with respect to the zero-day attacks?
So, as we went toward container security, we have like multiple. Container security is like onions. You have multiple layers, and the more layers you add, the more secure you are. So, I mean, we're still gonna have 0 days, but if you use things like SE Linux, you don't give root to your containers, you use an immutable host, then you can prevent the damage that 0 days is going to cause you. And also, like we talked about how OpenShift 4 is going to make it easier to roll out upgrades. So that will make the whole patching process easier when such an event occurs. I cannot promise you that no 0 day is going to happen with containers.
And this, at a higher level too, all the, Kubernetes has a large surface area because it has a lot of rich functionality, and that means that there's more attack surface there as well. And so the automated operations that we've been talking about all day long, it becomes more and more important because that's really your only defense is really active patching and being able to really react quickly. And that's just part of running infrastructure these days.
Yeah, I mean, one of the things that I like to, that was a great validation of the overall model is, many, many years ago, like in 2014, we had released Container Linux. It was still called CoreOS at the time. And, I was helping a local game development company kind of build out their online platform running atop Container Linux. And, in the middle of doing that work, Heartbleed came out. And I got a frantic phone call going, we need you to come in just later today. We don't even know when, just, not before noon, just we're going to be busy, Obviously, PKI is at the core of the actual signing of all of their games, so they want to make sure that, every game doesn't become free because of leaking that key material, et cetera. And they were very understanding that, there's only so much that all of these pieces can help, but, we've got a lot of things to do, come in later. So, I show up around, before noon, but go, hey, roll up my sleeves, I can help you any way I can. What do we need to get done? And they actually had finished up things earlier, and it was about 11:15, and they go, okay, we just went and got some more coffee. We took care of all of our legacy systems. Now we need to focus on all of the new development stuff. What's going on? How do we patch all these CoreOS systems? And I go, oh, those were done before you woke up this morning. It's patched. And they're like, what do you mean? Well, it's patched. That's why you're paying us. I thought that's what you wanted. That's the deal. And they go, well, no, but nothing went down. We didn't run it. It just. So we need to take care of this. And I said, okay, rather than tell, show. So just log into the machine and run OpenSSL version. And they do. And they're like, well, see, it's not patched. And then one guy goes, no, it is. That's the right version. And they're sitting there all confused for a second. And then they go, but nothing went down. Well, yeah, that's the whole point. You design things in a redundant manner. You design things to automatically update. That's why we push out things staged in the way that we do. And it was this brilliant moment where you see all of them start to go, oh, that's what we get out of this. And instantly, it was just no, this is what we want for everything. And is there any way we can do this with all the containers? How do we do this, can we make our applications, can we package them in a way so that we can push the updates out that way? It's yes, you can, and here is how, and let's work together. And so, that's why CoreOS and Red Hat are, together there. The whole idea is to kind of bring the forces to bear of giant teams of people who work through embargoed security issues and have things ready to go so that, in the event of a 0 day, obviously there's no embargo time for us to be working on that, but it is still that, we have thousands of ears to the ground to be aware of some of these things as soon as they crop up so that we can react and we can provide you the kind of SaaS-type delivery of things, but faster than your operations teams would be able to react.
Cool. Great story. Another question from the audience? If not, I'll ask. Oh, wait. Oh, he's got another one. Here we go.
So again, this is regarding security. Can you please comment on some of the startups which are trying to build the normal behavior of the containerized application automatically, and then they are trying to use that by watching in real time, and whenever there is a deviation, they want to flag it. So
I mean, that sounds a lot like, VeriSign's utilities that they built of proprietary kernel modules to, watch syscalls and then flag anomalous syscalls. And it also sounds a lot like work that SoundCloud had done early with Prometheus to kind of try to watch for anomalous metrics and alert on them. And unless you have machines building those models, first off, to begin with, it means you're going to be sifting through a mountain of data to try to figure out what the anomalies actually are and which ones are actual markers and which ones are just false positives. It also means that you need to have domain experts that are then understanding what the anomalies may mean so that they can begin working on that. And it's something where I would love to see that technology developed and demonstrate success, but I personally have not seen it yet. So I'll keep an eye peeled. But.
Another interesting thing related to this is like, so you want to, there's the onion like he was talking about. So you want to scan containers when they're built and pushed to a registry. You want to start doing active scanning of them while they're running. The question then is, what do you do if there is a problem on a running container? Do you yank it? Because you've got tools in Kubernetes to do that with admission controllers and stuff like that. Or do you just alert a team, or do you give a team a certain number of hours to react and then you yank it? Or like, it's a more organizational question at that point, like your culture too. How fast can you actually react and build a new container? And that's where all the automation is really key on that side.
Yeah, I mean, the folks at First Republic might decide that it's better to actually have an outage of the whole system than do something that might cause data to be leaked. Whereas, you're working for a startup game company, it might just be like, it's fine. Like, yeah, we'll get it, but please just alert us. And it really does become a case-by-case basis where different organizations may have different needs for kind of the way that the policy is enforced.
I can see everybody really just wants that beer that's outside. I have a couple, there were a lot of great talks today, and the C Group folks did a wonderful, I think it was the first time I really got the importance of going to V2, so thank you very much for that. But I'm wondering what it is, the takeaway that they should be, that we should be taking back to our organizations to help them better understand what's the next step. Like if we're using the early version, how do we sell that to enterprises to make sure that they do it and they help work on it in Kubernetes?
I'll take a stab and then you can go. I think the first step is if you do have workloads outside of the container space, this is technology that you can use today, and you can get a huge amount of the value that Taejun kind of walked through with the FB tax model, particularly in scenarios where resource management is a big deal. So it could be workload density, it could be multiple things competing on the nodes. So in a typical like enterprise environment, there's kind of the classic IT side, and there's like a million use cases where that's high value. And so you can flip a system to V2 and use that pretty easily today. Then I think from there, right, and this has been stable in the kernel since 4.5, so it's been a long time. From there, it's bringing that value into the container space, which is what we're kind of in process right now. And I think once people kind of grasp it for like the traditional use case on just running services, then it becomes a no-brainer to bring it into the container side. I don't know if you have any thoughts.
I don't have much.
Yeah, okay.
Yeah. Perfect, good.
Turn it on in Fedora.
Fedora 31,
Yeah.
probably.
It'll be there. It'll be there soon enough. So
Yeah.
that's good.
And it will be supported in RHEL 8 as well. Probably 8.1 or 8.2-ish is the plan.
Okay. So any other questions? Because I'll just keep asking them, because this is what I get to do. Every week I have a briefing or two that's videotaped and recorded. And basically what I do is I make people explain stuff to me. And I get to ask the questions.
You have a question back.
So is there one? Oh, good. Hey, Krish.
Hello. So is there a timeline when Kubernetes would require C groups to, or is it planned to work with both 1 and 2?
So we talked about this a little bit earlier today. Like right now, the V2 work can't even start because the underlying foundations of like runc and libcontainer aren't quite there yet. Like we're close on that. Like that has to be done before we can like even start the Kubernetes side. So, I think again, the work is going right now. Felipe's made huge progress over the past just several weeks. He just did a bunch of work over the weekend. God bless that guy. Love him. Anyway, we kind of need that to go a little bit further. Again, there's more OCI meetings happening this week to talk about it. And then once we get there, then we can like go tackle the Kubernetes side. So it's hard to put a date. I mean, a year-ish more. Yeah. I mean, it's going to be something like that.
Okay. Other question is for the Istio side of things. So in whatever production environments that you have, do you have an idea of what kind of overhead in terms of memory and CPU Istio adds onto your workload?
Sure. So I can say that for Red Hat specifically, since we aren't even at our GA yet, what we have decided to do is actual throughput and actual performance are non-goals for our GA, which we have been extremely clear about in all of our kind of marketing of saying, yes, other folks may be focused on this. We are focused on usability and focused on making sure that it's actually solving practical problems like the ones that we were talking about earlier. And we know, based on the pattern of usage from our customers, that there is a curve to the adoption. So but for our kind of 1.1 release internally of the OpenShift Service Mesh, once we kind of do the GA, we are going to kind of start with that as our benchmark and then start improving everything from there. I can tell you that it is also a hard question to ask because part of the challenge is the depth of the call chain. Because when you are thinking about the number of actual services that you're traversing through, that becomes, you know, an O of n squared problem as the call chain gets deeper and deeper and deeper. And so if it's actually a situation where if you have a monolithic service where it's just in and out, it's going to be negligible. If you have 25 different microservices or functions that are going super deep and you now have to go from machine A to machine B and then traverse a service and then go back over the network and back over the network and back over the network, you're going to see some amount of latency there, which, similar to the etcd question, means you are fighting against physics. So either we need to then work with better scheduling decisions to try to consolidate some of that, but we're not going to solve problems that don't exist yet. And that's part of the reason why we need to have our GA so that we can then have the benchmark and then solve the problems that are affecting our users the most, rather than just being like, maybe this one is the one that people are going to run into, or maybe this problem over here.
So I didn't understand the n squared bit of it.
Big O notation. So it's just
right. But why n squared and not 2n? Your call is going out and or.
Because if you are, well, I guess some of it is the direction of if you have to traverse, if you're doing direct server return in like load balancing, or if you are sending the responses back through the call chain, because as you go in from the gateway to the first service, to the to the first proxy, to the destination service, back to the first proxy, then out to the next proxy. There's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, so the second part of it was, I understand there'll be latency in terms of networking and even CPU, but how about memory overhead? Like, does the Istio control plane add a lot of overhead to just running an application on your cluster?
It adds some. It gets into how many of the mixer plugins you're using and which ones you're using. There are some that I don't remember the ones off the top of my head, but I know that there are ones that we aren't shipping by default just because it's unlikely that our users are going to be using those. But they are Go binaries, so the kind of traditional model is vendor things in and just keep pulling in stuff, which then increases the memory utilization. So it is something that we're keeping an eye on, but it hasn't been a lot. I mean, the big thing that I have seen is just, lot of communication when you are quiescing the actual state of the proxy topology, which, each one of those updates can be big because it's pushing an entire set of state when you actually push the update down to that. But at the same time, that's one that we knew would be a problem, and so folks from the Red Hat Istio team have been working on a proposal with the upstream called incremental XDS, where it's incremental updates across all of the various discovery services, so application discovery, service discovery, et cetera. And that allows us to just push down incremental changes to each of those, which dramatically lessens the amount of control plane traffic.
So that's a future Istio plan then?
It's been, I believe the proposal has been ratified in the upstream, and as Red Hat is oft want to do, we provided a reference code with the actual proposal. So.
Okay, thanks.
Mm-hmm.
All right. Well, I think the beer is out there. And I want to thank all of our speakers today. So if we could get a big round of applause for everybody who spoke. Some of you are there.